So my project in September is to look at extempore or extempore or whatever the pronunciation is. And the tagline for that project is something like cyber physical programming, which sounds a bit pretentious, I guess, but the idea is to have an environment, a real-time environment that you can interact with in real time using code. And it's pretty interesting. They built a system around the compiler toolchain LLVM and a scheme-like language, or a language that is a hybrid of scheme and a very similar to scheme language. I'm not going to go into those details, but I'm going to play a little bit with the language in Emacs. It ships with some Emacs macros, so it's easy to get started. And what I'm going to do now is to play a little bit with the audio system. There's a graphic system as well, so that you can do graphics and so forth, also in real time. But I'm going to focus on the audio bit for this one. So there is a standards library that ships with it, so it's pretty easy to get started. First of all, we need a process running, an extempore process, and my Emacs buffer is going to interact with that through basic telnet-like protocol, I think. So I'm going to do that now. So I will run extempore and it starts up. And then I'm going to start by loading this audio library here. And I'll do that. Oh, sorry. So the first thing I need to do is to connect this buffer on top here with the extempore process. So I think I'll do that by doing Control-X, Control-J. Okay, so we are connected. And I'll just evaluate these expressions here. And in order to get actual sound out of this, I will need to define a function which will be called by extempore in order to generate sound. So I'll do it this way. So those of you familiar with Scheme will notice that some of these variables are typed. That is the difference between Scheme and this XTlang that they've developed. Again, not going into details, but I'll make a function here that will take some parameters. It will take a sample in. It will take a time, channel, and something like that. And then I will return the sound, basically. So for now I'll just generate some white noise. So I'll do something like this. And I evaluate that one. As you can see down here, it compiled fine. There is no sound yet because I haven't connected this function with the Extempore DSP or audio backend, and I'll do that. It's easy to do that. I'll just write something like this. DSP is the name of that function, and if I evaluate this, we should get some noise. And we got some noise. So I put this with a not so large amplitude in order to not go deaf. We can turn it up a little. Or I'll just keep it like that. So as you can see, as soon as I change this function and I recompile it, the change is immediate. So this is working in real time. I think, without being too assertive, because I don't know the inner workings yet, I think the way this works is that Extempore will call this function ahead of time in order to fill a buffer. So it has the time here. It's probably the number of samples or something like that from the process started, or something to that effect, and it just will fill the audio buffer ahead of time. So obviously it can't do it too much ahead of time because then the latency of changes in code would be too big. Let's try to do something else. So now we've done a white noise one. Let's try to use the or make an oscillator, or maybe just do a sine for now. So instead of this, we will make something that makes a sine wave. So what I'm going to do here now is to do sine, and then those of you who are musicians might notice 440. This is a number of hertz. So this is an A, if I'm not mistaken. And then we will use the time as to determine, yeah, something like that. And then 440, this is the sample rate, right? So something like this, and if everything is correct, if I evaluate this, we should get a annoying sine wave. We did, with some noise as well. That's strange. Okay. And we can change the frequency of that. So half frequency would be something like that. Strange about the noise. Or this would also be an octave higher, right? So 0 hertz would result in no sound. So that's basically it. Now, this is obviously just the beginning, because what you would typically want to do is to generate a lot more complicated sound generating functions. And there's a reasonable number of options available from the Extempore library itself, and I will go into that in a later blog post. So I think we'll leave it at that for now.